In this lesson, we're going to use Kafka's partitioning semantics to create consumers that are horizontally scalable. That is, consumers that can consume more messages than a single process would be able to get through. So we'll have, say, 5 consumers running all at the same time, all picking up messages from Kafka. So to illustrate how partitions work in Kafka, let's use a drawing. So we're going to start with the broker, which will be right here. There's going to be a producer over here. So we'll call this the broker and the producer. Now normally, what we've been doing so far is publishing messages to a specific partition, partition 0. And we'll use red to indicate that. So that's 0. Then we have a consumer picking up those messages. And we only have a single consumer right now. Now with partitioning, what you do is at the producer, you specify what partition you want to write to. So the same producer can write to multiple partitions. So we'll say the green partition is partition number 1. Now this consumer here is already consuming messages from the red partition, or partition 0. So what we'll need is another consumer that's dedicated to getting messages from partition 1. So remember, when we write a message, we have a topic and the partition. So we can be publishing all to the same topic on different partitions. So the same producer is writing messages for, say, the topic BigData on partitions 0 and 1, and we have 2 separate consumers running at the same time. This one is dedicated to partition 1, and the other consumer is partition 0 rather, and the other consumer is dedicated to partition 1. All right, with that explanation, let's get to actually writing a producer that can write messages to 2 different partitions. So let's start off the producer. All right, we have Ruby gems in Kafka, and we'll just pick up from the command line how many partitions we're going to be publishing to. So we'll say partition count is going to equal first argument on the command line. Now, when we initialize the producer, we can actually do it the same way. The host will let be the default, which is localhost, and the port will be 9092. The topic will be big data scale. And here, we can specify the partition, but it won't matter because we'll be changing that later. And the truth is, partition 0 is the default partition when initializing the producer. So let's put a little output here so we know that it's running. And let's send some messages. Okay, so the first thing we need to do is figure out which partition we want to send to. And we already said that we're going to have 2 partitions, partition 0 and partition 1. So I don't really care which one it sends to, just as long as over time it tries to balance between the 2 of them. So let's just pick randomly between the 2. So random, the number of partition counts. Over time, we would expect an equal number of messages to be published to each partition. And let's just output something so we see what's going on. And we'll create a message. And we'll include the number of the iteration so we can track later on in the consumer that different messages are going to different partitions or different consumers. Finally, let's send the message. Okay, so that should do it for this. Now, before we run the producer, we're actually going to have to stop Kafka and update its configuration. All right, let's go into Kafka and look at its configuration. Here, we have the number of partitions that a broker can handle. Now, we're only running one broker, so to make this work, we'll just say we can handle 5 different partitions. One important thing to note is that each partition on a topic is a separate file, so it's a good idea to keep the total number down to a reasonable number. And now we can restart Kafka. All right, and starting Kafka back up. And redirecting standard error to standard out, and everything out to our local file. And now let's start Kafka back up. All right, we see the Kafka server started. Let's go back to our producer and run it now that we have multiple partitions created. Okay, so it seems to be sending data to the different partitions 0 and 1 in a fairly random interval. Let's write a consumer that can pull data off of those partitions. Okay, so we're requiring Ruby gems in Kafka, so we can work with them. We'll read the number of partitions off the command line as before. And initialize the consumer, just like we did with the producer. We'll use the default host of localhost and the default port of 9092. We'll specify the topic, big data, scale. And in this case, we're not pulling off the partition count from the command line. We're actually pulling off the partition that we want to read from. Remember, each consumer is going to be dedicated to pulling the data from a single partition. That way, you can have multiple processes running at the same time consuming messages. Now let's output something to make sure we're consuming messages from where we think we are. And let's loop through and consume messages. Remember, the loop command gets yielded an array of messages. All right, our consumer's done. Let's test it out. We'll run this Ruby consumer on partition 0 and see if we can publish messages to it. Okay, so it's listening in on big data scale on partition 0. Now we'll start up the producer and tell it there's only one partition to send to. So all messages should go to the 0 partition. And here we see all those messages. Now let's tell the producer that there are 2 partitions to send to. Here we see a few of the messages went to partition 1. And sure enough, we're missing some messages in the cycle on this consumer. And that's because we'll need to start up another consumer that reads from partition 1. Here's our Ruby consumer that reads from partition 1. Okay, big data scale partition 1. And here's our other consumer reading from partition 0. Let's clear this out so we can see new messages only. And now let's run a producer to send messages. So here we have messages to both the 1 and the 0 partition. Here we see the 0 messages. And here we see the messages sent to partition 1. Using this technique, you can run multiple consumers at the same time on a single topic. Generally, you want to have only one consumer running per partition, which means once the volume of messages going through a partition gets too high for a single consumer to handle, you'll want to partition it.